I observe that the militarization of space, long anticipated as future threat, has in the past 3 years transitioned from theoretical possibility to operational reality, fundamentally altering the nature of terrestrial conflict and creating systemic vulnerabilities that few populations understand and no institutions are prepared to manage. The satellites upon which modern civilization depends for navigation, communication, weather forecasting, financial transactions, and military operations are now explicit targets in great power competition, and the weapon systems designed to destroy or disable them are being tested, deployed, and normalized as legitimate tools of warfare despite the catastrophic cascading risks that their use would trigger. I trace this not as technological development abstracted from consequences, but as analysis of how the infrastructure that enables contemporary life has been weaponized without public deliberation, international regulation, or consideration of the fact that space, unlike terrestrial battlefields, cannot be quarantined once conflict begins. Debris from destroyed satellites does not fall to Earth and disappear. It remains in orbit at velocities exceeding 17,000 miles per hour, creating permanent hazards that render entire orbital zones unusable for decades or centuries. What I document is the construction of a system where military advantage is pursued through capabilities that, if used, would destroy the very infrastructure that all parties depend upon, creating conditions where deterrence may fail not because actors are irrational, but because the complexity and fragility of space systems makes accidents and miscalculations inevitable. I begin with the Russian anti-satellite weapon tests because they establish the precedent that space assets are legitimate military targets. In November 2021, Russia conducted a direct ascent anti-satellite missile test, destroying one of its own defunct satellites and creating over 1,500 pieces of trackable debris plus countless smaller fragments. The test demonstrated Russia's capability to destroy satellites in low Earth orbit, the zone where most reconnaissance, communications, and navigation satellites operate. The debris field created hazards for the International Space Station, forcing astronauts into escape vehicles as precaution, and will remain a collision threat for years. The United States and NATO condemned the test as reckless and destabilizing. Russia asserted its sovereign right to test defensive capabilities and accused the West of hypocrisy given American development of similar systems. I analyze what this test revealed beyond the immediate technical demonstration. It showed that Russia, facing NATO conventional superiority and economic sanctions, views space systems as high-value targets where asymmetric attack can impose disproportionate costs on adversaries who depend more heavily on satellite infrastructure than Russia does. American military operations are fundamentally dependent on GPS for precision weapons, on communication satellites for command and control, and on reconnaissance satellites for intelligence gathering. Degrading or destroying these systems would severely impair American military effectiveness, and Russia has calculated that its own lesser dependence on space infrastructure makes this exchange favorable. The test was message. In future conflict, American space assets are not sanctuaries but targets. I examined China's satellite inspection and capture capabilities because they represent a more sophisticated and potentially more destabilizing approach than kinetic destruction. China has developed and demonstrated satellites with robotic arms capable of approaching, grappling, and maneuvering other satellites, ostensibly for debris removal and servicing purposes, but with obvious dual-use military applications. A satellite that can capture debris can capture functioning satellites. A capability marketed as peaceful space cleanup is simultaneously a capability to disable, hijack, or deorbit adversary assets without creating the debris field that kinetic weapons produce. China has conducted multiple tests of proximity operations, satellite inspection, and robotic manipulation in orbit, building operational capacity that exists in legal gray zone. The Outer Space Treaty prohibits weapons of mass destruction in space, but says nothing about conventional weapons or dual-use technologies. I trace the American response through the expansion of the United States Space Force, established in 2019 and rapidly growing in budget, personnel, and mission scope through 2025. The Space Force is tasked with protecting American space assets, ensuring freedom of operation in space, and developing capabilities to deny adversaries the use of space in conflict. This includes ground-based anti-satellite missiles, space-based interceptors, electronic warfare systems to jam or spoof satellite signals, and cyber capabilities to hack satellite control systems. The institutional logic is deterrence. If adversaries know that attacking American satellites will trigger retaliation against their own space infrastructure, they will refrain from initiating space conflict. But this logic assumes rational calculation under crisis conditions, functioning communication during escalation, and confidence in attribution, assumptions that terrestrial warfare repeatedly demonstrates are unreliable. I analyze the Starlink precedent because it collapses the distinction between civilian and military space infrastructure in ways that fundamentally alter targeting calculations. SpaceX's Starlink constellation, comprising over 5,000 satellites in low Earth orbit as of 2025 with plans for tens of thousands more, was developed as commercial internet service but became critical military infrastructure when it provided communications to Ukrainian forces after Russian invasion disrupted terrestrial networks. Starlink terminals allowed Ukrainian military units to maintain command and control, coordinate artillery strikes, and operate drones despite Russian electronic warfare. The service was initially provided through private arrangements, then formalized through U.S. government contracts, making Starlink explicitly dual-use infrastructure. I examine the targeting dilemma this creates. From a Russian military perspective, Starlink satellites are now legitimate targets because they provide military communications to an adversary. But attacking the constellation would require destroying thousands of satellites, creating debris fields that would render low Earth orbit unusable, not just for military purposes, but for all satellite operations, weather monitoring, GPS navigation, climate observation, scientific research. The catastrophic consequences would affect all nations, including Russia itself, yet the military logic of degrading adversary capabilities may override these considerations if conflict escalates. The fact that Starlink is nominally a private commercial system provides no protection. The distinction between government and private satellites is operationally meaningless when both serve military functions. I trace the Kessler syndrome risk, which represents the civilizational scale threat that space militarization creates. The syndrome, named for NASA scientist Donald Kessler, who identified it in 1978, describes a cascading collision scenario. Debris from one satellite destruction impacts another satellite, creating more debris, which impacts more satellites, creating exponential debris proliferation until entire orbital zones become unusable. Current debris tracking identifies approximately 30,000 objects larger than 10 centimeters in low Earth orbit. Millions of smaller fragments exist but cannot be tracked. Each piece travels at orbital velocity, meaning even paint flecks can destroy satellites on impact. A major anti-satellite weapons exchange, destroying dozens or hundreds of satellites, would likely trigger Kessler syndrome in the most densely populated orbital zones, rendering them inaccessible for decades. I analyze what civilization loses if low Earth orbit becomes unusable. GPS navigation fails globally, affecting everything from aviation to shipping to precision agriculture to financial transaction timestamps. Weather forecasting loses satellite data that provides hurricane tracking, flood prediction, and climate monitoring. Telecommunications lose satellite capacity that provides internet access to remote regions and backup communications for terrestrial networks. Earth observation satellites that monitor deforestation, glacier melt, ocean temperatures, and agricultural productivity cease functioning. Military forces lose reconnaissance, communications, and navigation capabilities that modern warfare depends upon. This is not temporary disruption. Orbital debris persists for years or decades before atmospheric drag causes re-entry. The civilization that has built critical infrastructure dependency on space access would face permanent loss of capabilities that have become fundamental to how societies function. I examine the treaty vacuum that allows this escalation to proceed without legal constraints. The Outer Space Treaty of 1967, signed during the Cold War, prohibits placing weapons of mass destruction in orbit or on celestial bodies, and declares space the province of all mankind to be used for peaceful purposes. But it does not prohibit conventional weapons in space, does not define what constitutes a weapon versus dual-use technology, does not establish verification mechanisms, and provides no enforcement capability. Subsequent agreements attempted to limit anti-satellite weapons development, but none achieved binding international status. The result is that space militarization proceeds in legal gray zone, where capabilities are developed, tested, and deployed with only non-binding norms as constraint. I trace why new treaties appear impossible under current geopolitical conditions. The United States, possessing the most extensive and capable space infrastructure, seeks to preserve freedom of action and prevent agreements that would constrain its technological advantages. China and Russia, seeking to offset American space superiority, refuse limitations that would lock in their inferior positions. Verification of compliance with space weapons restrictions is technically complex given the dual-use nature of most space technologies, and no state trusts competitors to honor agreements when strategic incentives favor violation. The institutional mechanisms that produced arms control during the Cold War, mutual vulnerability, creating shared interest in stability, bipolar clarity, simplifying negotiations, extended timelines allowing trust building, do not exist in contemporary multipolar competition over space resources and capabilities. I analyze the escalation dynamics that make space conflict particularly dangerous despite all parties recognizing the mutual catastrophe it would produce. Space systems are fragile, expensive, and take years to replace, creating incentives for preemptive attack if conflict appears imminent. Better to destroy adversary satellites before they can be used against you than to allow them to degrade your capabilities while you retain intact targets. Attribution of attacks is difficult. Satellite failures could result from natural causes, accidents, cyber intrusions, or physical weapons, making proportional response uncertain. The speed of engagement is measured in seconds for some systems, compressing decision timelines below what human deliberation can manage. Communication with adversaries during crisis is unreliable when the satellites that enable secure communications are themselves under attack. These dynamics create conditions where crisis instability, the pressure to strike first rather than risk being struck, operates more intensely than in nuclear deterrent scenarios. I examine the commercial sector's role in exacerbating these risks through the proliferation of mega-constellations. Beyond Starlink, Amazon's Project Kuiper plans thousands of satellites. China is developing comparable systems, and numerous other commercial ventures are launching constellations for internet, Earth observation, and various services. This proliferation serves civilian purposes but creates military vulnerabilities. More satellites mean more potential targets, more debris if conflict occurs, more congestion in orbital zones, and more difficulty distinguishing military from civilian assets. The commercial incentive is to launch as many satellites as possible to capture market share. No regulatory authority limits this proliferation based on sustainability or security considerations. The result is orbital commons tragedy, where individual rational decisions collectively produce systemic fragility. I trace the civilization dependency that has developed largely without public awareness or political deliberation. GPS has become so embedded in infrastructure that its loss would paralyze transportation, disable precision agriculture, disrupt financial systems relying on timestamp synchronization, and eliminate navigation capabilities that populations now take for granted. Communications satellites enable internet access, media distribution, and emergency communications for regions without terrestrial alternatives. Weather satellites provide data essential for disaster preparedness and climate monitoring. This dependency was not imposed, It emerged through incremental adoption of technologies that proved useful, but the cumulative effect is that modern civilization cannot function without space infrastructure, creating strategic vulnerability that adversaries can exploit. I analyze whether deterrence can prevent space conflict or whether the structural conditions make it inevitable. The argument for deterrence rests on mutual dependence. All space-capable nations rely on satellites, so none would initiate attacks that produce debris fields affecting everyone. But this assumes that decision-makers in crisis prioritize long-term collective interest over short-term military advantage, that they have perfect information about consequences, and that no accidents or miscalculations occur. History of terrestrial warfare suggests these assumptions fail regularly. The argument against deterrent stability notes that asymmetric dependencies create incentives for the less dependent party to strike, that the inability to distinguish civilian from military targets undermines restraint, and that the irreversible nature of debris creation means that a single failure of deterrence produces permanent consequences. I examine the absence of public deliberation about decisions that create civilizational scale risks. The militarization of space has proceeded through defense budget allocations, weapons testing programs, and commercial satellite deployments, none of which triggered public debate about whether the benefits justify the systemic risks. Populations are not asked whether they consent to infrastructure dependencies that make them vulnerable to conflicts they have no control over. They are not informed about the Kessler syndrome risk that could permanently deny humanity access to space. They are not presented with alternatives that might preserve space as sanctuary while accepting constraints on military capabilities. The decisions are made by military planners, corporate executives, and politicians operating within institutional logics that prioritize competitive advantage over collective security. I return to the core question, why has space become militarized despite obvious mutual interest in preserving it as stable commons? The answer is that the institutional structures governing great power competition, national sovereignty, security dilemmas, technological races, and the absence of enforceable international law operate in space exactly as they operate terrestrially, but the consequences are qualitatively different because space cannot be cordoned, because debris persists indefinitely, and because the infrastructure at risk is genuinely global rather than territorially contained. Each state pursues advantage, each responds to others' capabilities with countermeasures, and the collective outcome is an arms race that all participants recognize as potentially catastrophic, but that none can unilaterally exit without accepting strategic disadvantage. I conclude with the systemic implications. Space militarization reveals the limits of deterrence when infrastructure is fragile, when attack advantages are significant, and when consequences are irreversible. It demonstrates that international law cannot constrain behavior when enforcement mechanisms are absent and when strategic incentives favor defection. It shows that commercial technologies with dual-use capabilities blur civilian-military distinctions in ways that undermine targeting restraint. Most fundamentally, it exposes that modern civilization has constructed dependencies on infrastructure that exists in an ungoverned commons accessible to all actors, creating vulnerabilities that no defensive measures can fully mitigate. The space wars have not yet begun in earnest, but the weapons are deployed, the targets are identified, and the conditions that would make conflict catastrophic for all parties are fully established. What remains uncertain is whether institutional learning can occur before the first major exchange, or whether humanity will learn the consequences of space warfare only through experiencing them.